Very good morning. So in the last class, we discussed about some of the types of non-conventional source of energies, that is what renewable source of energies. In continuation with that, today's class, we are going to discuss another important type of a non-conventional source or renewable source of energy called biomass, and one more is ocean thermal energy. First one is biomass energy. We already know that biomass energy or biomass means it is a energy generated or produced by a living or a non-living organisms. It is generated by living or non-living uh, things. Biomass, it's purely an organic matter. Uh, it is made up of materials that comes from living organisms such as plants, animals. Okay, the most common biomass is that what we are using to generate energy is plants, wood, and agricultural waste. Okay, so in the picture you can see. So these are the some biomass sources. Okay, first thing is the source for biomass is biomass means it is purely an a organic thing which is a living or non-living organisms. It is called biomass, and the source for this biomass is okay. The biomass is plentifully available on the earth crust. Okay, it is abundantly available on the earth crust. The source for this biomass is first thing is a agricultural waste. You can see this is what the agricultural waste. Next, the forestry crops or resources in the forest. Okay, and sewages from the urban areas. Next, municipal solid waste. Again, it is from the urban areas, and animal residues, maybe cow dung. Okay, so animal residues and industrial waste, industrial resources. So these are all what the resource for a biomass. By these things, we can extract the biomass. Okay, from the animals, we can extract the biomass. From the plants, we can extract biomass. And this biomass is also a indirect form of a sun, solar energy. It is also a indirect form of solar energy. From the sun only, we get this biomass energy. Without sun, we cannot get biomass energy. Okay, first the sun is the source. From the sun, that energy is absorbed by either plants or animals. Then from the plants and animals, we get the energy. That energy is called as biomass energy. It is an indirect form of energy. Okay, the potential for the application of biomass is an alternative source. It is an alternative source of conventional energy sources. We have plenty of agricultural waste and forest resources for production of biomass. The biomass is produced in a nature through the photosynthesis. What I told, it is an indirect form of solar energy. So this is achieved by with the help of photosynthesis from the solar energy conversion. So the simplest form of this reaction means the simplest form of this photosynthesis reaction means solar rays. We already studied these things in our school days and in our PUCs. Okay, so how this process is taking place? The photosynthesis is a simple chemical reaction. It is taking place in the presence of solar energy. Okay, and the plants will absorb CO2, carbon dioxide, and water H2O, and in the presence of solar energy, it will convert that H2O plus CO2 is converted CH2O plus O2, means it will release the oxygen, and it is having an some content CH2O. It is called carbohydrates. It is purely organic matter. It is generated with the help of H2O plus CO2 in the presence of solar energy. This process is called as photosynthesis process. Okay, so this photosynthesis process liberates the oxygen. It is very much required for our human beings for respiration process. And second important the thing is CH2O, that is called organic material. This is a rich in carbohydrate with a low temperature, and again this carbohydrates CH2O can break with a can break this link and releasing an and it will liberate enormous amount of energy, which may equal to that heat energy or energy, or it liberates energy or heat energy, which may equal to 112 kilocalories per molecule. Okay, that is what 469 kilojoules per molecule. That much of amount of energy is released while burning of one molecule of this carbohydrate CH2O. So that reaction is CH2O, for combustion purpose need oxygen. Okay, with the help of oxygen only the combustion will taking place. So CH2O plus O2, okay, that liberates CO2, carbon dioxide, plus H2O, water particles, and enormous amount of energy, 112 kilocalories per molecule. That much of amount of energy is released. This is what a combustion process. Okay, the combustion means the combustion of plants or any animals. If you combustion taking place with the help of oxygen, it will liberate carbon dioxide. Of course, it's a pollution for the atmosphere. Plus, along with it will liberates H2O, water particles, along with that enormous amount of energy. And this energy can be utilized to for any useful applications like cooking purpose, for heating purpose, or generation of electricity. For that, we can continue this energy. The absorbed energy of photon should be at least equal to this amount, and this is therefore a possible to produce a large amount of carbohydrates by growing. Means this amount of energy even we can generate with the help of algae. Under we can grow the algae. Okay, and under optimum conditions, in a pond we can grow some algae. Okay, that algae could be harvested and dried and burned for production of heat, could be converted into electricity. Either we can directly go with the plants, or we can with the help of algae only, we can first harvest this algae, and we can grow this algae, and we can burn this, and we can generate the enormous amount of energy, heat energy. Okay, by this what we get is heat energy. Simply if you take a plant, okay, or an wood is the best example. If you burn the wood, it will liberate uh, carbon dioxide, that is in the black color. Along with that, it will generate large amount of heat. You can feel that heat. Okay, that means the rising the temperature. Along with that, it is also produces a water, H2O particles. Some slight water drops will generated, or a byproduct of this combustion. And the biomass is used directly by burning or further process to produce a more convenient as a liquid form, as a gaseous form, or as a solid form. Means this biomass is having an three important states. When the biomass is in solid, it is a solid biomass. For example, wood or agricultural waste is a solid form of biomass. Second type is a biomass in the form of a liquid. It is biomass is in the form of a liquid. Okay, so this is what liquid means, either liquid or a fuel. It's a non a traditional form. Means we get for this example is biofuels, biodiesel. Okay, biodiesel, nowadays biodiesel is one of the best example for this biomass. We can extract the biodiesel from the agricultural waste, or even animal waste. We can extract these things. It is used as a best replacement for diesel. Not 100%. We can use with a some blended form. Means if 80% if you use diesel, 20% used as a biodiesel. By combining these, we get an effective a fuel for replacement of a conventional source of energies. And if the biomass is in the form of gas, means it is in the uh, biogas. It is called as a biogas. This is a biomass anaerobically to obtain a gas. Aerobically or anaerobically, there is a two process which converts this biomass into gaseous form. Okay, this biogas is of 50 to 65% of methane. means whatever the content is in biomass is methane is the main source. Next 30 to 40% of carbon dioxide, and the rest is H2, H2S, and means sulfur, nitrogen. These are the residues of this biogas. So biogas mainly contain methane or ethane. Then next percentage is having an carbon dioxide. And this biomass is there are so many. I told there are so many source for this biomass. Okay, maybe from the waste of municipal waste, we get the biomass. From the sewage, we can get the biomass. From the agricultural waste, we get the biomass. From the marine, we get the biomass. Even from the fish, also fish means marine waste. From the fish also we can extract the biofuels. From the plants we can extract the biofuels. From the seeds also we can extract the biofuels. Even from the kitchen waste, the vegetables, okay, vegetables or the fruits or vegetables, okay, once they are not not to use, okay, so once they start decaying, they will start fermenting, okay, they will start slowly, fermentation will starts and start producing the carbohydrates, a rich carbohydrates form, okay. From that we can extract, by fermenting we can extract the biofuels. Next is even we can get this biofuels by energy plantation. So another way of getting bio energy is energy plantation for the large scale production. For this is for the industrial purpose. Okay, for the industrial or for the electric generation purpose, we can go with this energy plantation. For the large scale production of electric power, the use of the fire as a fuel. We know that for generation of electricity, we have to burn the fuel. Okay, if the coal is not available, then we have to go with the wood or agricultural waste. By burning of this wood or agricultural waste, we get the energies, and that energy means that raw material is for the boilers. Okay, in the boilers, by the combustion, that energy is generated, and that energy is used to make water to steam, to convert water to steam, okay, in the power plant. Then that steam is through some processes that will converts mechanical energy, then mechanical to electrical, then for the useful form. Okay, so this is how we can generate a that biomass energy to the electric energy. For this we need a large amount of wood or tree for the combustion process. So first we have to go with the plantations. The so which select the species of trees. Not for all trees are used. Only a particular species of trees we can use for this process, and we have to plant those trees, those plants, and then harvested over a regular time period. Then land near the power plant. Okay, that too near the power plant, and large areas is required for this. We need a large areas, and trees for which generally suggested are eucalyptus. In Kannada, we can call it as a Nilgiri. So Nilgiri tree, or you can call it as a eucalyptus. It's the best example. Next, another important tree is Babilo. So Babilo is the another tree, and these two type of trees are generally suggested to plantation. Once the plantation over, then cut those trees, because those trees are only meant for this combustion process, and cut the trees and then dump into the boilers for generation of heat. And next, of course, solid biogas is already directly we can use, and biofuels. I told the biodiesel also you can extract from the animals, from the seeds, and from the agricultural waste, even from the napier grass. From the grass also we can extract the biofuels. I think in two years back, I did with the help of our students, our project students, we did a one beautiful project, extraction of biodiesels from the napier grass. Napier grass means it's a dry grass, a dry grass generally available on the land, dry land. Okay, from the using of the dry grass, we extracted the biodiesels. First, cut that grass. Okay, then just like a sugarcane machine. Okay, from that, using the same sugarcane machine, extracting machine, uh, through that grass will squeezed, and we get the some liquid, and that liquid then with the help of algae or yeast, okay, for the 21 days, then it will completely fermented, and after 21 days, then we separate those waste as well as liquids. Okay, they are clearly transparent, and we get the transparent liquid. Then through the distillation process, okay, we extracted the biodiesels. So this is how we extract the biodiesels. Means that biodiesels mainly having an ethanol. Ethanol is the major source for that biodiesels. So and we did this project, and also KCST sponsored our project, and also got the well appreciation for our project, and it is also selected for a state level KCST show. So like this, we can extract the biodiesels. Then that biodiesels, we through some experimental process, means that biodiesels is used in the along with the diesel, and blended with the diesel some percentage, and we effectively run our IC engine, two-stroke and four-stroke, and we got better efficiency when compared to a solely used diesel. Next is a biogas. We already know that this is one of the biogas, means it is in the gaseous form. The main source of production of this biogas is a wet cow dung. It is commonly seen in the rural areas, wet cow dung or wet livestock. Even human is also used. So human waste or animal waste or cow dung is a main source for this to produce the biogas. The production of this biogas is a particularly significance in the most in our India. Most of the villages are used this biogas, generation of this biogas for their cooking or cooking purpose or heating purpose. And the main source for this biogas is a sewage, crop residues, agricultural waste, vegetable, whatever the kitchen waste, vegetable waste, okay, water, poultry droppings, and algae, and another whatever the animal waste is a main source for this uh, biogas. From this, we can extract the biogas. Okay, this is a one example. So in the second picture, you can see these animals. Okay, and here biogas tank is there. From that, extract the biogas. Then it is through some processes we can convert that energy into the electric energy. So this is a one picture. Later I will show you how it works. Uh, So come to the biogas. Before that, I'll show you how this works. Okay, biogas plant. So one video is there. I'll show you the biogas plant. So this is a video. So here, how we use. So this is a biogas plant. It's a dome-like structure, and it is made by bricks. Okay, and it's an inlet and outlet. It's a one gas chamber, and here there is no oxygen. In the absence of oxygen, and first we input the with a inlet, okay, bio waste or agricultural waste or animal waste, and here it is not completely filled, it is partially filled. And here what happens in the absence of oxygen, there is an anaerobic process will takes place, the fermentation, and with a time period it will forms the carbon dioxide, hydrogen, nitrogen, that is what the gas. This is what we call it as a biogas. It is placed at the above the digester. This is what the digester, and here there is a waste. After producing the biogas, this is a waste. It is called as a slurry, and it will extract, and it will use for the of course for the agriculture purpose. And this gas, whatever the collected in the gas above the digester, this directly through the pipeline we can connect to the cooking purpose. For the cooking purpose, for the heating of the water, we can use this gas. This is the one layout how we convert this waste into the useful form of energy. Uh, Next, come to the another plant. This is a industrial purpose. Here we plant the tree. That is what plantation of trees. And after once they grow enough, then they will cut and into the boiler section. Where the boiler section there is a burning of these trees and produces a lot of amount of heat, and that heat will converted into electric energy. Then it is through the generators, and they will through the grids they will collect it and use for the uh, rural or urban area electric need. And this is how some of the applications. Before that, we have to discuss the some of the advantages and disadvantages of this biomass. So advantages means it is a renewable source. I told it's a indirect form of solar energy, so that it is an renewable. It is a inexhaustible. It's a non-conventional. The energy is stored, it's inbuilt and future of it. We can store this energy, we can use it in the future. And this is an indangerous source of energy. We no need of any foreign exchange or foreign needs. We can generate in our country only, and it is a clean and eco-friendly when compared to the coal and other form of energies. Of course, it is having some sort of carbon dioxide, but even when it is compared to the coal, it's very less. The forestry, agricultural waste, we can easily dumped for this process, and we can used to generate the energies for the rural areas, mainly for the rural areas. And the pollutants are also very less. It's a clean and clear source of energy. And come to the disadvantages, of course, it is an uh, land intensive, means it need a large amount of space for the generation of energy. Means we need a large plantation areas where we can grow the plants and use for as a raw materials. And when compared to the coal, it produces a low density energy. The density of energy is very less. Means the combustion, after the combustion, whatever the energy is getting, it is very less when compared to the coals or petroleum or any other source of conventional energy sources. It efficiency is less. Of course, we get the energy, but efficiency is less. And it need a laborers, labor intensive and cost and large quantity of commercial applications it needs. So these are all whatever the disadvantages of this source of energies. And come to the applications, I told through these are all processes, 1 2 3 4 5, these processes we can get or we can convert this bioform into a useful, that is what biohydrogen we can generate, then bioethane, that is what biogas, biodiesel I told. And this diesel is used for the to run the automobiles. Then as a jet fuel also we can use this biohydrogen. Then fuel gas for the industrial purpose. Then biogas, then bio oils. Okay, these are all some of the applications where we can use in the marine applications, in the transportation purpose, industrial purpose, even in the for the jet or aeroplane we can use. So these are all some typical applications of this biodiesel, and this is a one best replacement for crude oil applications. Crude oil means a conventional oil. It's also called as a crude petroleum oil. It's a best replacement. Okay, we go with the next type of energy. That is what? Ocean temperature difference. It is called OTEC, Ocean Thermal Energy Conversion. It is from the ocean temperature difference. So this is also an another indirect form of solar energy, or from the sun. From the sun, what we are getting, so many types of energies. In that, this is also one type of energy. It is a secondary form of solar energy or indirect form of solar energy. Okay, so this ocean thermal energy means here we know that ocean is a huge, it having a huge amount of water, oceans. Okay, when compared to the land, in our earth, the ocean is having a more space than the earth, than the land. So land early, if you're having an around 20 to 25% of land, and rest 70 to 75% of the is covered, the earth is covered by water, that is in the form of oceans or sea or a large ponds. And these are the main source for extraction of uh, electricity. Of course, we can generate electricity or any useful form of energies. So here oceans, so ocean having an three different layers. So depth of the ocean is very high when compared to the rivers. Okay, when compared to the river, the depth of the ocean is very high. Ocean may having an 2 or 3 or 4 or 10 kilometer depth. Ocean is having a huge amount of depth. Okay, and this ocean, there are three layers, three important layers. The first layer, okay, or surface, it is called as a surface or top layer, and intermediate layer, and the bottom layer or deep water layer. Okay, so these layers having a different temperatures. Always these having a different temperatures. uh, the top layer always having a higher temperature, and middle or intermediate layer is having an, so here there are, you can observe in the figure. Okay, the first ocean having an some temperature in the higher temperature in the top layer, and intermediate it's having a moderate temperature, and in the bottom there is an another temperature. Okay, so this difference in the temperature, we can, this difference in the temperature we can use for generation of energy. So this process is called as OTEC, means ocean thermal energy conversion. So this is another indirect method of utilizing solar energy. I already told a large amount of solar energy is collected and stored in the tropical oceans, and the surface of this water is act as an collector for solar heat. Means the whatever the heat from the sun is directly collected in the top layer of the ocean, and the surface of this water is collected or absorbed. And while the upper layer of this sea constitutes infinite energy storage reservoir, means it will store those energy in the top layer only, so that the top layer always having a higher temperature. Thus the heat contained in the ocean could be converted into electricity by utilizing the fact that the temperature difference between the warm surface of the water and in the tropical oceans, and there is an colder water in the depth about 20 to 25 temperature degree centigrade, that much of difference. Utilization of this energy with this associate temperature difference can be conversion into work. The difference in the temperature can be converted into work from a basis of a ocean thermal energy conversion system. This system we can use to convert that energy difference into work, then work into mechanical, then mechanical into electrical, we can generate. Okay, the surface of water which is higher temperature could be the used to heat. Means here this temperature approximately, you can take 100. And this if the water, the overall depth of this ocean is, let us assume that it is a 2 kilometers or 3 kilometers depth. Okay, 3 kilometers mean 3000 meter or 5000 meter. Hello, please can you mute your audio? Okay, thank you. So here, let us assume that if the depth of this water, the ocean is 5000 meter, okay, or 5 kilometer or 5000 meter. First, whatever the 500 meter is a top layer. 500 meter, let us assume as a top layer. Then from 500 to 1500 or 2000 intermediate, and from 2000 to 5000, whatever that is a deep, that is a bottom layer. So the top layer, because of the sun, it will absorb the energy from the radiation and stored, so that the temperature of this always may be like atmospheric temperature, or maybe higher than the atmospheric. If it is 36, 37, 38, let us assume 38 or 38 to 40 degree temperature, the temperature of the top layer. And intermediate is having a less temperature, maybe 10 to 20 degree centigrade. Okay, and the bottom layer, so bottom layer always having colder, means it is less than 10 degree centigrade, the 10 degree centigrade. So that the temperature difference between top layer and the bottom layer is, if it is a 38 and here it is 10, means there is a 28 degree centigrade difference. 28 degree centigrade difference. So this difference in the temperature we can use to generate some work, and that work can be converted into another useful form. This is how we can convert that difference in the temperature. Difference is ताने. So here there is a high temperature 38 degree, and in the bottom layer it is a low temperature colder, means 10 degree. So difference in the temperature that we can use to generate the work. Okay. And some important properties of water. We already know that water, okay, so when it is in the solid form, it is cold, means less than 0 degree centigrade. It is in the form called solid form. It is example ice is a example. Next, by gaining the temperature, it will convert solid to liquid, that is what water form. Then from water to next higher form means steam. Again, by gaining the heat, it will change the phase. Okay, these are the three phases of water. So by using these three phases, we can extract some work. Okay, so here first here there is a system. Okay, there is a system you can observe in the figure. So these are the turbines, or these are the processes we are used to convert, or we can extract the energy from ocean thermal temperature difference. Okay, so here this blue color and in the orange color represents the hot energy, and this blue color represents the somewhat a cool energy. Okay, less, it's a war, and it's a cold or condenser, it's evaporator or hot energy. So here turbines. Okay, here we are using a less means here we are using in some what refrigerants or some media or some substances. What we are using is those substances are by gaining small amount of heat, they will change the phase, and by giving small amount of heat they will again change the phase. So that type of substance what we are using in this process. Okay, so these substance are uh, continuously operate, and if it is complete a one cycle, means from the evaporator to condenser it completes one cycle. Okay, so it will continuously operate in the same cycle for n number of cycles to generate the heat. So here we are using pump to pump the cold water, and in the top layer of course it is having an higher temperature water. Okay, so here evaporator is there. Okay, in the evaporator, once that fluid, whatever the sensitive fluid is in the evaporator, always this evaporator in the top layer. So because in the top layer it is a warm, it is having a higher temperature, it's a warm layer. And here what happens when the that sensitive the substance, sensitive substance is in the evaporator, by absorbing heat from the top layer, by absorbing heat in the top layer, it will change the phase from liquid to gaseous. Then that gaseous fluid with an high pressure, it is into the turbine chamber or generator. In the turbine with a high temperature and high pressure, it will operates the turbine, or it will rotate the turbine, and it will rotate these turbine blades and rotor and shaft, means it will produce the mechanical energy. Then mechanical energy is directly connected into the generators, where we can convert mechanical to electric energy. Then once the electric energy is generated, then it is taken for any other respective useful applications. Then after doing this work, whatever the fluid is there, by giving that energy to the blades or to the turbine, then after losing energy, again it will back into the condenser. Okay, the same fluid into the condenser, where the condenser is completely surrounded by cold water, means the water which is in the bottom layer, it's a cold water. Okay, that cold water is used and to cool this condenser. Okay, in the condenser completely filled by the cool water, and in the condenser where this fluid is passed through, while passing it will give the heat to the whatever the cold water. So the cold water will absorb the heat from the fluid and change the phase from gaseous to liquid. Okay, in the condenser means it will condense the fluid. Again, once this fluid is from the same condenser again pumped. Okay, from the pump it will pump again into the evaporator. So this is a one process, okay, one cycle of process. Here hot water enters from the top layer and evaporates, and cold water from the bottom layer, it will remove the heat, and the same amount of fluid is from change the phase from liquid to gaseous, gaseous to liquid, and while passing it will generate the heat. So here the heat energy is rotates this turbine and generate the electricity. This is how this is the best example you can see in this figure. So here also same thing, cold water intake, hot water intake, okay, and here mixed to water, and it is returned into the oceans, okay. So here the hot water used to in the evaporator, where the fluid change the phase from liquid to gaseous, cold water in the condenser, where this change gaseous to liquid. While doing this, it will operate, it will do some work, and that work again is to uh, generate the electricity or any other useful form. This is we can achieve with the help of top layer and bottom layer, because there is a difference, clear difference between the heat. And this is a one graph you can see, while the temperature is 0 degree, where it is in the 4500 meters, more than 4500 meter, the temperature is 4 to 5 degree, and slowly when the depth is decreases 4000, 3500, 2000, 1100, 800, you can see it is an intermediate. And in the top, whatever the top surface, it is of temperature 22, 34, 35, or like this, okay, 20, 24, or 30, 30, 35, like this, there is a temperature. But in the bottom, it is a temperature less than 4 degree. So there is a clear difference in the temperature. By this difference in the temperature, we can utilize for generation of maybe electricity or any other useful form of energy. So this is another figure which shows that the temperature difference in the evaporator and temperature difference in the condenser. Condenser always it is a 3 to 7 degree, and in the evaporator it is 25 to 35. Okay. And I'll show you one video with respect to this, how this ocean thermal. Okay, this is a ocean thermal energy conversion. And here there is a ocean, and this one is what, it's a top layer and the bottom layer. So blue color is a cold water, and this orange it is a warm water. This is a evaporator, this is a condenser. Okay, so condenser completely surrounded by a cold water, and whatever the substance we are using, it is ammonia. Ammonia is a one substance. Okay, it is a evaporator. It is evaporator coils surrounded by a top layer, and these coils, they are closed. Okay, and this is a turbine, and this is how that coil, okay, here gain the energy and run the turbine, and after the run the turbine, it will into the condenser, where it will lose the energy. And this is a closed one and continuously operating one. And come to the advantages and disadvantages of. Okay, so come to the advantages and disadvantages. The first important advantages is it's a clear, there is no air pollution, there is no combustion, so that there is no chance of air pollution. It won't produce any carbon dioxide, sulfur, or nitrogen, etc. Okay, it's a clear. A second thing, it decreases the reliance on the foreign oils, like petroleum oil or whatever the foreign oils we export from the foreign countries. It will decrease the dependency on those oils, reduce the CO2 emission, because there is no combustion, so that there is no chance of emission of carbon dioxide. And it has a potential to meet all world energy needs. By using this difference in the energy, we can generate the energy, and that energy can needs or fulfill whatever the energy requirements on the earth. Okay, and of course at the same time it is having some of the disadvantages. It's more expensive than compared to the fossil fuels, because fossil fuels are directly take from the earth crust, and directly through some small process distillation process, we can extract the different types of fuels, and by combustion of those fuels we can directly get the energy. But here we need a large processes, large setup, because we have to take water from the bottom layer, then we have to install the turbines, we need lot of setup, so it's a more expensive, and must be an area, it's need a very large area, and it need a ocean. Without ocean we can't generate this type of energy, because that ocean must having a some warm water on the top layer, and bottom layer there is a cold water, because cold water to condense, warm water to evaporate. That's why we need, and we need a lot of pipelines. Okay, if the pipeline damages, if pipeline or if any that coils, that coil, within the coil that fluid substance is flowing. Okay, if it is damaged, it will stop entire process. Okay, and also efficiency, and ultimately efficiency, the efficiency is very less. Non-conventional source or renewable source are having a very less efficiency compared to the conventional ones. Conventional ones always having a higher efficiency, because directly combustion we get a enormous amount of energy, so that efficiency is very high. But here the efficiency is very low, but the efficiency is continuous one. It's a inexhaustible, regenerating, and these can utilize for, or these can replacement for our renewable, non-renewable sources. And applications, again turbines, mainly the turbines are used to convert that ocean temperature difference to the work, and that work into mechanical energy, that mechanical energy into electrical energy, and that electric energy can take into the urban areas, or any industrial applications, or whatever the need of energies we can effectively utilized. Okay.